All right, so in F, we have to do a little bit. Oh, so first off, my bad. So we want to find where our function might be undefined. So 1 plus the natural log of x could be 0 when the natural log of x is equal to -1. Remember, the natural log is the log base e, right? So this is log base e of x is -1. So this means e to the negative first power would be x. So that's going to be a vertical asymptote for us. That's going to live on our table of signs. Also, natural log of x, just x as a domain, domain is always x is greater than 0. So our domain is going to be 0 to e to the -1. And then again, e to the -1 to infinity. All right, so got to keep that in mind, right? Because this e to the -1 is going to be important for a derivative. All right, so when we take a derivative, we're going to use a little bit of a quotient rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. All right, so we can pull the e to the x out. We're going to get 1 minus 1 over x plus natural log of x over 1 plus natural log of x squared. All right, so when we think about what could and what couldn't equal 0, so e to the x, this is never 0. This, in fact, is always positive, so it's not going to affect our table of signs. 1 plus natural log of x. So we already found that it's only equal to x at e to the negative first power, but that's not in our domain. Since it's squared, it's also always positive. So the only thing that has a chance to be 0 would be this thing. So let's see, 1 minus 1 over x plus natural log of x could be 0. Technology, I'm going to use technology. I don't know. So I'm just going to plug in here. I'm going to hide that. 1 minus 1 over x plus natural log of x. So 1, right? So 1, really? Natural log of 1, 1. Oh, yeah, that makes sense. Natural log of 1 is 0. 1 minus 1 over 1 is 0. So 1 would be a critical value. All right, so our only critical number is going to be x is equal to 1. However, we do want to think about e to the negative first power in our function as well. All right, so we're going to plug these things into our derivative. And again, right, look at the only thing that could be positive or negative. It's this, right? This is the only thing that could be positive or negative. So if I have 1 minus 1 over x plus the natural log of x here, here, and here. Let's see. So if you plugged in something between zero, I'm just going to throw some technology. So if I plug in something like e to the negative second power, let me do that, right? So e to the negative second power. So I'd have 1 minus, so remember, e to the negative second power is 1 over e squared. So I'd have 1 over e squared. So that's going to be an e squared. Natural log of e to the negative second is minus 2. So e squared is definitely bigger than these things. So I'm going to get 1 minus minus. This is going to be negative. So our function is going to be decreasing. If I throw in something between e to the negative 1 and 1, I don't even know what that is. E to the 1/2, right? That'll work. That'd be there's one. So e to the 1/2. So we're gonna get 1. I mean, this is gonna be 1/2. This is gonna be no, that was still gonna be plus 2. So that should be a -1/2. So that's gonna be a -1/2. So we're going to get minus, this would be like 1 over e to the 1/2. So we're going to get minus e to the 1/2. I don't know what square root of e to the 1/2 is, but I think it's probably bigger than this. So it's going to be negative again. You know what? Just let's use technology. Boom, let's turn this thing back on. All right, so there we go. Our function is decreasing from 0 to 1 over e. We're decreasing and then we're increasing. So we're decreasing again, and then we're increasing. And remember, this was a vertical asymptote. So this is going to be a min of our function. One critical number, we're decreasing from 0 to e to the negative 1. And then again from e to the negative 1 to 1. So that's going to be our answer. And then we're increasing from 1 to infinity. 1 to infinity. We're going to have no max. No, nothing there. We're going to have a critical number when x is equal to 1. Can we plug 1 to that thing nicely? E to the first power, e1 plus natural log of 1, which is just 0. It's going to be e to the first power. So there's going to be our minima. There you go. Beautiful.